This is a bit of history. I started playing around with using a laser cutter that's at the Maker Labs in Vancouver and cutting out shapes. This was my first experience in doing CNC stuff, and it was kind of fun. It was kind of cool. I liked what I could do with it. I have a long-running history with fractals. I used to draw them by hand in my notebooks when I was in high school, and so I just have this weird ongoing obsession with them, and it was really cool to see them cut out of material. Anyway, the pipeline to get that is I would make my shapes in Houdini, and then I wrote an SVG file exporter. Now, I've looked online since then, and there are a lot of SVG file exporters for Houdini that people have written. It's an XML file format, which is really friendly with Python, so pretty easy to write them. They're easy to find, and the format is not necessarily perfect. So I got this free software called Inkscape, and I would open up my SVG file and save it back out just to make sure it was working correctly. The laser cutter worked great for that. This was, the pipeline, relatively straightforward. So all it took was just for me to make my shapes and then write an SVG file, and I was good. Then I got online, and I found this drawing robot from Alibaba. I thought, well, that looks cool. I want to do something with that. It was only 120 bucks or so. So I was like, I ordered one up and I assembled it. It's got an Arduino down at one end with a couple of motor controllers that drive 2 servo motors for the XY and 1 servo motor to lift and lower the pen. Sorry, stepper motor, not servo motor. Altogether, 120 bucks about what it would have cost me to put that together myself. Pretty nifty little item, with all the linear bearings and stuff, and I decided to try and drive it. So I found out that the Arduino is supposed to be running a software called Gerbil, G-R-B-L, then you would feed G-code to that from over USB. Now what I had going as a pipeline is that I would work in Houdini. I would export an SVG file, which I would then dump out to Inkscape. And then I would have to find a G-code generator. And there are several. Some of them are plugins to Inkscape. They really are designed, the laser cutter engravers are pretty common in the world. They're used commercially and stuff. There are a lot of them. And there's a lot of G-code generators that work well for laser cutter engravers. And for CNC routers and for water jet cutters and other CNC devices. But these little drawing machines, they're not really, they don't have a commercial application. And this like lift a pen, put it down, and it's a different set of criteria of what you need for this. And I just couldn't find anything that would spit out a decent G-code file that I would feed to the Gerbil for the drawbot. And so I was struggling with this, and I tried reformatting my SVG files. The plugins to Inkscape didn't like my SVG file. It was really baffling me, and it dawned on me, what the hell, why don't I just look up what the hell is in G-code? And there's this web resource that I found very handy. It's called Wikipedia. You may have heard of it. And they have a whole page on G-code. So I dumped out a really simple bit of G-code and read through it and looked at the Wikipedia page. And I found that it was actually not that complicated. So G-code was originated in the 1950s. It's really old. And it was originally meant for punch tape. And so it was nothing too wildly complex. So with this new system now, I could just dump G-code directly out of Houdini, which then could get sent to the Gerbil and to the drawbot, which made it much, much simpler again. So that was my plan. So now open Houdini. This is, here's an L system to make some big crazy piece of geometry. Koch Snowflake, or Koch Snowflake? I don't know how to pronounce his name correctly. I always thought it was Koch, but then I found out it might not be. But anyway, this is the G-coder. It's a very simple little Python soft that I wrote. I found that they had these different controls for Z up speed, Z down speed, draw speed. These were typical controls on some of the G-code generators. And frankly, I wound up setting them all equal to the same number. So I'm going to be sending out a version of this. I'm probably going to simplify it down a bit. There really is only one speed, and I just set it to the maximum, just to something huge. and then there's a Z up location and a Z down location. So what I do is I want the pen to start resting on the paper, then I want to lift it up, move it to someplace, then put it down slightly below the paper and have it draw. And that way it's got a little bit of pressure on it. The device actually has a rubber band on it that puts a little bit of pressure. And then for the node, I wanted to have an out file that I would enter, and I wanted to have a button. I didn't want it just to cook every time the sock cooks. So this is the node that I put together, and this is, I'm going to open this now and take a look at the code. So the basics, there are the parameter controls. They're pretty straightforward. And the code itself has pretty much nothing. I just make sure that it's flat in Z. So it doesn't really do anything in terms of the code. But the scripts, I have a script because this is where the meat of the activity happens. When you push that button, it calls this function, write file. So this is all in Python. And as you can see, it's quite short. So what I do is, given the quarks that come in, I get the node and the geometry. Then I get a bounding box. I found an issue very quickly early on where it would start drawing and it would leave the edge of the paper halfway through a drawing. And this was a problem for me for some reason, especially when it took 4 hours to do a drawing, and 3 hours into a drawing, it went off the edge of the paper. So I realized that first thing it has to do is it has to trace around the bounding box while the pen is up in the air, so you can watch it and make sure that it's going to be on your piece of paper. And if it isn't, you can move your piece of paper around and make sure that it will be on the piece of paper. So I get a bounding box, and I get a min V and a max V from the bounding box. Then I get the up speed, down speed, which is how quickly it pulls it up, how quickly it drops it down. The up location and the down location, the draw speed, and then they have this thing called rapid for most G-code generators. I don't use it. I just set it equal to, it's always draw speed, which is always maximum. And I'll get into why in a moment. So then I have an out file. So G-code, the first thing you do is you set your units and your absolute position with these two G-code calls, which is why it's called G-code. And I got the information on this from the Wikipedia page. Very simple. And I did write out, I managed to get one piece of G-code written from a plugin that was through a triangle. And reading through that, I just kind of took it apart and followed what it does. So it would set these two values at the beginning. I had a bunch of other crap at the beginning that doesn't do anything. But then I would set this Z location, which would be the upload, basically we pull it up. Then I go and march, this one I added later. This is going around the bounding box. So this goes around the bounding box. And then for prim in geoprims, for every single location, I set its X and Y. And then the Z, down location and down speed. Then this is the starting. First I set it to whatever the 0 point of the prim is. Then I loop over the prim for all the vertices in the prim. So it goes in vertex order. It has nothing to, it ignores point order. It goes around all of the vertexes, and for each one it sets the XY location and then draw speed. And it just dumps this all out to a simple file. Then when it's all done, if the prim is closed, then you have to return to your starting point and close the prim. And then G-code, when it's all done, I found that I needed to go back up and then return to 0, 0. So that that way I have the ability to change pens, although I have yet to do that. So this has actually gotten slightly more complex than the original, but it still is, it's all of, how many lines of code? 19? Oh, 50 lines of code. And I looked everywhere and could not find G-code generators being thrown out there very often, but this is really nothing to be scared of. So a lot of people have written SVG exporters. Those are pretty complex compared to directly deriving G-code. And now I have the ability to control the speed that it goes up, the speed that it travels around, and so on. Let me close this now. So I have some, let me open the videos. Here's a video, time lapse video of it drawing the Koch snowflake, or Koch island rather, that you saw there. This is, I believe, this took quite a while. I think it was like half an hour. Some of my settings, I found that on the gerbil, the way that gerbil works and the way the Arduino works is that you have an app on your laptop that's connected, and you make edits to it and then download it. And then you can keep your laptop or other computer connected by the USB and send the G code over, and gerbil will interpret it based on the settings that you gave it. Now, this particular setup is kind of unusual. These two motors here, there's no motor running X. The X and Y motors are on either side. So, and it's got this big cross-shaped band that goes through there, which is what they call core XY. So I had to get it running core XY, and after running it for a while, I found that I could change the settings so that it would run faster. So tuning gerbil is definitely one of those things that you need to do. And then here is a close-up of it drawing. I hope the audio is coming through. No audio? Oh, some are hearing the audio.
Well, we can hear you, but I can't hear the anymore.
Oh, you can't hear this thing going? Darn.
No,
okay,
we can't.
Well, I will hook you up with the actual machine in a minute. So that's real time. And then here it's drawing a more complex fractal Julia set. And this really was kind of fun. I found that you can feed it a polygon with around, or you can feed it around 100,000 points or so, between 1 and 200,000 points, and that seems to be. I'm actually. There's a couple of computers involved in this. First of all, there's the Arduino that's actually driving the motors, but the Arduino doesn't. It just accepts G code. You have to have something sending the G code, and I'm using a Raspberry Pi for that, because I want my laptop free to do other things when it takes hours to print. And so that Raspberry Pi, it really kind of gets weighed down when you have more than 200,000 points in your file. As it is, with 200,000 points, it takes probably 2 or 3 minutes to open the file, just to draw it to screen, before it allows you to start playing and sending the G code. So that was what I had. Let's see, what else was I gonna? Here, I'll show you some of, let me switch from screen share. So it just drew this one. Let me set it up. Actually, here, let me just hit play again, see if it will do it again. Yep. So I don't know if you can hear the motors. It draws the bounding box. And then it goes to the starting point, drops the pen, and starts drawing. So it's off by a little, it must have slid. So can you hear the motors? Yes. It's actually kind of fun to listen to. And it's not wildly loud. I had a 3D printer that I was playing with before that was annoying to be near. This one's kind of fun to listen to, and you don't really hear it when you get a distance away. Yeah, make music with it. How long did which one take? Here, I'll show you some of the prints that I've done now. I'm gonna hit stop on this. So while playing with it, here's some of. Let me just free this guy. So you can see this. That's probably one of the more complicated ones. I was playing also with doing hatching, and this one here, you can see that I don't think it focuses pretty well. The resolution is actually a higher resolution than the width of the pen, so it's pretty accurate. And this I did after adjusting the gerbil settings so that it would draw faster, and I think that was 3 hours to draw this, 3 or 4 hours. So it is time consuming. I've been playing with the hatching algorithm. So this came from a photograph originally, and then I did a cross-hatching on it, and I also used a trace sop based on a Sobel filter from COPS, which extracted the outlines of where an edge detect.
I got a quick question. Are you playing with the height of the pen to get just a line that's slightly thicker or not?
No, I have not been, and I would need to use a felt tip pen for that, and that is a possibility. And I was realizing that actually, I think I can control the full X, Y, and Z in such a way that I might be able to get it to stroke neatly with like a nice pen, but I haven't. This is fairly early on. Really, the purpose of this is just to let everybody know that this is not something to be scared of, I guess. I haven't really dialed in anything too wildly high tech, but I did print quite a few of these Julia sets. I really have a love for the Julia sets. So this is from the Seahorse Valley. The C value came from the Seahorse Valley of the Mandelbrot set. This was my first print of the skull. I found some issues with different pens, and oddly enough, the absolute cheapest pen I could find has so far turned out to be the best. So I've done quite a few Julia sets, and I actually got a couple of frames, and I got a couple. This was one of my early ones, but this one was kind of fun. This is the same as the one that I had laser cut in plastic. Caught snowflake. So one thing that I noticed, here, let me do this. I'm gonna change the file that it's loaded. Well, okay, I'm just gonna close this. Sometimes it's better just to close it. There, let me put you so you're not so shaky. Okay, so this has been a bit of exploration, learning how to, what the details are and what's important. And one thing that I noticed, which surprised me, is this. Okay, so I'm using this. This is the Raspberry Pi. So I don't know how familiar you guys are, but this is the computer right here. So instead of my laptop, that's what I'm using. And that's driving the monitor, and it's sending the G code, and it's doing all of the heavy lifting, quote unquote. So, let's see now, this here. This is just a triangle. In fact, I will remove the pen and show you something that I noticed. I noticed this pretty early on. I was struggling. It was on my triangle file that I noticed this. When I was struggling to get this thing to work, it expects to be all the way in the corner as a starting point. I just made a big triangle, and I hit play. And if you listen carefully, the motor accelerates and decelerates. Now, I did not put that into my G code. So the gerbil interpreter actually carefully looks, it analyzes your file, carefully adjusts it so that it does not accelerate too quickly, doesn't go around corners too quickly, etc. You don't have to worry about that. It handles all of that for you. So that's a big part of why tuning the settings in your gerbil will adjust the time that it takes to draw a picture enormously. So that's definitely an important thing to do. But that's pretty much it. So I mean, the real reason that I was kind of presenting this was just to go through the process of problem solving that I went through to hey, well, how do I get this thing to happen? I want this crazy cheap thing that I got on the internet to work. What am I going to do? And when it starts to look like things are going to be a real nightmare, sometimes the easiest thing is just to roll up your sleeves and write a little bit of code. And sometimes it turns out just to be a tiny little bit of code. So that Python code doesn't need to read in any weird libraries or anything, and it's 50 lines of code, and it allowed me to generate all of this artwork. So that's it. Any questions?
Awesome.
Yeah, guys, it's really damn cool. It's a really cool project. I wanted to know how do you initialize the robot, because it seems difficult to get a starting position.
Well, I actually found that it was difficult to get a starting position. It was really hard to get G-code generator. That was actually the killer for me. I could not understand how the G-code generators that are available out there figure out their initial starting point, because I would put everything very close to the origin, and it would put it really far away, and I'd have to let it run, stop it, back it. You can physically move it. So if you hit pause, you can move it around. So it would start drawing and would come all the way across my paper. I would hit pause, and then I'd push it back by hand, and it would start drawing again, and then I'd have to hit pause. And you can do that. You can actually move it around. And originally, I have this now taped down, but originally I did not have it taped down, and I would let it run, and then I would move it around until I had it in the position that I wanted it on the paper. Now that it's taped down, which is actually kind of made it a little more reliable, I have to move the paper around if I need to adjust where it falls on the paper. And I just tape the paper down, which, not necessarily the nicest, but it works. So, and I actually, by experimentation, came up with, I don't think that this is calibrated exactly. I think you can calibrate it exactly. I didn't. But I just figured out approximately how big it is, and then in my Houdini scene file, I threw down a grid that's roughly the size of a piece of paper, roughly located where a piece of paper is. And so when I'm done making some shape that I like in X and Y in Houdini, I'll scale it until it fits approximately on the paper where I would like it to fit. And I'm finding that it's not accurate, but I could calibrate it with some time and effort.
Also, do you have to calibrate how the pen falls? Do you just have to put the pen in and just put it on the paper?
It took me a while of experimentation to learn, actually, on that one. What I found is that what I do is I put it in the corner. I try and have it fall on a piece of tape. Is that in frame? Yes, that's in frame. And then I set it up so that I would drop the pen all the way to the piece of paper and tighten it. And then that's the 0 position. And then from there, it lifts up, moves to position, drops down, and then starts drawing. So that sets 0. And when it's all done, I now have it returning to 0 because I want to start experimenting with switching pens halfway through. So I can do multicolored drawings and stuff.
Something that could be really cool would be trying with, instead of using a pen, you could try to use a brush.
Yeah, I was thinking about that. I tried using a felt tip pen, and I actually found because it's kind of mushy, it made, let's see if I can find it. This is one of the first skull drawings, and every single line has, I was calling it sort of a hockey stick shape at the beginning and end. And it makes kind of all of the, like the white area, kind of visually, it looks almost like it's been outlined with a dark line, which is, I found it detracted from it. But if I could learn to control it properly, it might be good. So if I'm really carefully controlling the X, Y, and Z, I could imagine that a brush would probably be amazing, but it's going to take a lot of effort. So yeah, it might be interesting to experiment with, for sure.
Also, are you able to kind of make curves, or it has to
absolutely.
be? Oh.
Yeah, I don't know if you can see the detail. Well, no, this one didn't finish. Yeah, it definitely does curves quite nicely, actually. And again, underneath it all, I'm making a polygon, so it's a collection of straight edges. But if you make enough of them, they're a fraction of it seems like the resolution that I'm getting right now with 100,000 points is probably about half the width of the ball in the ballpoint pen. So you can get curves that are extremely smooth, and it's actually kind of nice sounding on the motors when it's doing curves. Like it drew the outline of that skull. Where did I put it? Right here.
So did you try to make a circle, for example?
I haven't. I could do that right now, but it'll take a second. But yes, it should do a circle quite smoothly. It seemed to handle curves without an issue. So I mean, this is quite, curved.
Yeah.
And I handled it quickly and smoothly and accurately. So.
I guess this would translate to any sort of machine that is very similar, like a CNC router.
Absolutely. I mean, the thing is that when you're once again, the requirements for this drawing machine are different than for other CNC machines. It's actually in many ways simpler because you just have a line. You want it to go where the line is. For like a laser cutter or a CNC router, you almost always, you have a part you're trying to cut out. So you have a line and you want it to cut such that that line is left. So instead of being in the middle of the line, it has to know the size of the bit you're using, and it has to offset by a distance, and it gets quite complex. You could also use this, this could generate G-code for a 3D printer as well. And again, those algorithms start to get quite complex because, again, you want to know the width of the filament, and you want to offset by the correct amount, and so on. And all of those things are possible. And frankly, I'm a little surprised that when I searched around, that no one else has made a G-code generator that I could find for Houdini. It seems like an obvious fit, trivial to make this simple one. And I think that was part of what motivated me, was that the drawing machine is simpler than what you really need for anything else. And I couldn't find anything that did it. But I did just get a CNC router, so I'm probably going to experiment with generating G-code from Houdini for that too. And that's going to involve all of those complexities of offsetting stuff. But,
Cool. Cool. Were there some more questions for Ivan?
I got the last one. I'm pretty sure it's not possible. There's no way to rotate to change the inclination of the robot. It would be nice to be able to on the cube, something like that.
Yeah, yes, I know. Especially if you had like a calligraphy pen or something, you can lock the pen at an angle, but you can't rotate it with this setup. Now, in theory, this is just a little piece of plastic. I could mount a servo motor on there and add an extra, dimension on there. And Gerbil looks to me to be extensible enough that it would be able to accept the extra G code for the extra axis.
So drawing on volumes, that would be amazing. Yeah. I'd love to see that.
Yeah, I was thinking about that. Like you could have it so that you could make a model of the shape and then have it draw on an undulating surface. Might be an interesting thing if you had one. Yeah. Anyway.
Cool. Let's see. Are there any other people who have questions about the plotter and G-code?
I think my question would be like, what's the future? Are you planning to do some kind of apply this to a CNC machine, cut in some metal? Do you have some design ideas?
I mean, to a certain degree, what you're seeing is what my original goal was with this machine and with the G-code generating directly from Houdini. My plan was to make art.
Okay.
I used to draw fractals in my notebooks with pen for hours, and having a machine do it for me is somehow very appealing. And it's, of course, much more precise than I was. I could never draw a Julia set.
Absolutely. Very cool.
Yeah. But I do now have a CNC router, and I'm considering, possibly generating G-code directly from Houdini. Although you can also simply the CNC router and like plasma cutters and those things, they have very serious software that generates G-code from like SVG files and stuff, and it has very complex algorithms that will set the tool speed and so on. None of which is an issue for this, but. Yeah.
So what you're saying is basically like what you're doing here isn't necessarily compatible with, let's say, a CNC machine.
It might be, but you would probably find that a commercial product takes into account other things that I may not.
Yes.
So I don't know how well the commercial machines would handle like the triangle test, for instance. Gerbil on this does an acceleration and a deceleration nicely for a pen. Now, I don't know if Gerbil on a CNC router would necessarily accelerate and hold it at the correct speed for a cutting tool. And that's an issue that certainly could be experimented with. It might. So
probably a little bit more learning and more Wikipedia. I'm sure it's very doable.
Yep.
Cool stuff, though. Thank you.
Yeah. other questions?
Yeah, I've got another question here from Ed. Ed asks if you've tried this code on any other machines or plotters.
I have not tried this G-code on any other machines or plotters because I do not have another plotter. I do have a CNC router that I just got. It's a kit. I have almost finished assembling it.
Everyone's really excited about the CNC router, I think.
Oh, okay. Well, it might be cool to see it in wood for sure.
For sure. Great. So I think I'm just going to open it up for questions one more time. Let's see if we get any. No.
All right. There's a question for Ed. Which pub are you going to? So, for people that are not in the Vancouver, in the VHUG, usually he organizes going to the pub after the VHUG.
Unfortunately, no pub today, but we can do a virtual toast, I'm sure.
Yeah, I'm not in a pub, but I figure since I'm here, I would go walk outside and.
There we go.
That's
Squamish. Nice.
That's a pretty nice pub patio, I'm not gonna lie.
Yeah.
$1 million
I can't make it to the pub, but I think I'll hoist one for you.